Notes 37, using the elimination method. Before we do that, though, we're going to review finding the solution to the system of equations using the graphing method. So we're first going to move our negative 2x over to the other side, which will make it a positive 2x plus 1. So when we go to graph it, we start at 1 and then go up 2 over 1, up 2 over 1. Then we will draw our line. Okay. And then on the second equation, we're going to move our 6x over to the other side, and it goes from being a positive 6x to a negative 6x minus 8. And then we're going to go through and divide every single term by 2. So we get y equals negative 3x minus 4. So we start down at negative 4. Now then, I can't go down 3, right 1. It'll take me off the graph. So I'm going to go up 3, left 1. And that point falls right on that red line, which is the point of intersection. So that's left 1, down 1. You could check this by plugging in negative 1 in place of y, negative 1 in place of x there. And you'd find out that 2 times negative 1 is negative 2 plus 1 is negative 1. So it's equals to each other. This is a new concept right here that we haven't showed you on the calculator, so you can take your time and try that out. So it'd be a good time to pause and put that in. Now, remember, whenever you add another equation, when you're graphing, you have to use the tab button. All right, let's take a look at solve systems of equations using the elimination method. So first of all, there are 3 different methods of solving the system of equations. One is graphing that we practice, and the other one is elimination. Now, I'm going to show you actually the second part of the elimination method. So we're going to kind of work backwards. And it says all answers to systems are either an ordered pair, which most of them are, unless they are infinitely many solutions, which means it's the same equation, or no solution, which means the lines would be parallel if graphed. So given a system of equations with one of the answers given, x or y, practice getting the second answer. And it says right here, you can plug the number into either equation. It really doesn't matter. So on problem 1, you can see that x is 3, and I'm just going to use this first equation. So we're going to make this a 3 right there. And then it's just a 2-step equation where we subtract 3 from both sides. So 2y equals 4, divide both sides by 2, and y is equal to 2. So that's there. And then you can check it. So I'm just going to use the second equation here and check it. So 2 times 3 minus 2. So 6 minus 2 does give us 4. So what this means is, if you were to take these 2 equations, solve for y, and graph it, this is the point of where those 2 lines would intersect. Problem 2. This time negative 1 is given for y, not x. So I'm just going to use that second equation. So I'm going to put a negative 1 right here in place of y, and then a 2-step equation. I add 1 to both sides, so I get 3x equals 9. Divide both sides by 3, and x equals 3. And then you can check it into either equation. So here's a 3, here's a negative 1, so this is 6 plus 1, and that does give me 7 to check out. All right, let's look at the back side. On 3 and 4, this is where you can actually choose which equation to plug into first. So this would be a good time to pause this and to see if you can do it correctly. I'm going to go ahead and use, let's just use the bottom equation here. So I have 4 times negative 2 plus 2y equals negative 10. So that gives me negative 8 plus 2y equals negative 10. Then I'm going to add 8 to both sides. So I get 2y equals negative 2. I divide by 2, and y is negative 1. Then I'm going to check it. So since I have a little more room above the word check, I'm just going to go ahead and use that bottom. I'll use the top equation since I just used it. Use the bottom equation. So I have 5 times negative 2 plus 2 times negative 1. We'll see if that gives us negative 12. So negative 10 minus 2 does give us negative 12. All right, let's try over here number 4. This time our y is given. I'm going to go ahead and use this top equation right here. So we don't know what our x is, minus, but we know that our y is 23. And this equals negative 8. We're going to add 23 to both sides. And x is equal to 15. And then you can use either equation. I'm just going to use top equation. It's actually a little bit easier. So our x is 15 minus our y is 23. Does that give us negative 8? Yes, it does. All right, before continuing, you need to understand these concepts. That 2x minus 2x cancels out to be 0. Negative 5y plus 5y cancels out to be 0. X minus x cancels out to be 0. However, 1y plus 1y is 2y. It doesn't cancel out. So right here it says, what is needed to make the variable cancel? Well, if I have a negative 3x, I need this to be a 3x. If I have a 2y, I need that to be a negative 2y. All right, so now we are going to actually start using the elimination method. Eliminate means to get rid of. So when columns are lined up correctly, we're going to add the columns. You need one of the variables to cancel out. Eliminated. All right. So on this one, you have a positive 2y and a negative 2y cancel out. So now I have 1x plus 3x gives me 4x, and 7 minus 3 is 4. Divide both sides by 4, and x is equal to 1. That's fairly easy. So now, guess what? This is what we've been practicing this whole time, is finding out what the second answer is. So you can use any equation. I'm just going to go ahead and use this equation right here. My x is 1 plus 2y equals 7. I subtract 1 from both sides. So 2y equals 6. Divide both sides by 2. And y is 3. So there we go. Now if you want to check it, I'm just going to go ahead and use the first equation. So is 1 plus 2 times 3, which is 6. Does that give me 7? Yes, it does. All right, problem 6. So 5, the y's canceled out. Well, on problem 6, the y's are going to cancel out again right there. So then I have 3x minus 1x gives me 2x equals 32. I divide both sides by 2. And x is 16. I'm going to go ahead and use this one. So I have 3 times 16 plus y equals 20. So this is 48 plus y is 20. Subtract 48. So y is negative 28. That's a big number. All right, so I'm going to go ahead and use that bottom equation to check. So it says a negative x, so that would be a negative 16 minus a negative 28, which would be a positive 28. Does that give me 12? Yes, 28 minus 16 does give me 12. All right, let's take a look at 7 and 8 here. Now on problems 5 and 6, you notice that the y's canceled out first. Well, on 7 and 8, the x's are going to cancel out first. Now, this is a mistake that seems like students make. They think that these y's should cancel out as well. But this is actually 1y plus 1y, which is 2y, equals 36. Then you're going to divide both sides by 2. So y equals 18. I'm going to use this top equation. So we have x, we don't know yet, plus our y, we just found out to be 18 equals 30. Then we're going to subtract 18 by both sides. So x equals 12. And I'm just going to go ahead and use this bottom equation right here to check it. So negative x, so that would be negative 12 plus y, which is 18. Does that give me 6? Yes, it does. It checks out. Problem 8. Our x's cancel out. 5y and 5y is 10y equals 9 minus 9 is 0. Well, when you do 0 divided by any number, you get y is 0. I'm going to use this equation right here. So I have 3x plus 5 times 0 equals 9. Well, 5 times 0 is 0. That cancels out. So basically, we just have 3x equals 9 divided by 3. So x equals 3. Okay, I use a different color. Boom, green. Okay, so let's just use this bottom equation here. So we have negative 3 times our x, which is 3, and plus 5 times 0. Let's see if that gives us negative 9. Well, 5 times 0 is 0, so negative 3 times 3 is negative 9 is equal to negative 9. So that checks out. That is using elimination.